kids, for math today, you are going to need your math binder and a pencil out for this video because we are going to be going through some of the problems together, and that way you can fill it in right during the video. That way you won't have more to do later. So I'd like you to open up to the page that says, it's page 58, read tables. I'm going to present my screen so that you can see what my paper looks like. So you should be on the page that looks like this. It says read tables. Joanna collected information about the type, weight, and lifespan of several dog breeds. Information like this is called data or data. Joanna organized the data into a table. A table uses rows and columns to display information. So if you look at Joanna's table, she titled it Dog Breed Information. And in her columns, she has what is the breed of the dog, and then she lists them down here. What type of dog is that? What is the average weight of the dog in pounds? And what is the average lifespan, or how long it usually lives in years? So if we look at this table, I might say, okay, how many pounds is a Great Dane usually? Well, to figure that out, I would go to Great Dane and then go over to pounds, and it says 115. So we can use this table to answer questions. If you look at number 1, it says, what is the average weight of a dachshund? So we're going to find dachshund, and then we're going to go over to weight. What is the average weight? 24 pounds. So that is what I will write right here. I'll write 24 pounds. Now I'm going to make that a little bit bigger so you can see it. There we go, 24 pounds. The next question says, which breed in the table has the shortest lifespan? So in order to do that, I need to go over to the lifespan column and find which one has the shortest. Well, I see it looks here like 7 is the smallest number. So I'll go over and look, what kind of dog is that talking about? A Great Dane. So I will write Great Dane in. Number 3, it says, which 2 dogs are sporting dogs? Well, that's this type of dog. It talks about toy, hound, working, sporting, non-sporting, herding, terrier. So I'm going to find where it says sporting. And what 2 types does it talk about? Labrador Retriever and Cocker Spaniel. So that's what I would write in for number 3. I'm going to make a little shortcut there. Okay, Labrador Retriever and Cocker Spaniel. Now my final question says, what is the difference in average weight between a Great Dane and a Jack Russell Terrier? Now, whenever you see that word difference in a question, it's asking you to subtract. So it wants to know, what is the difference between a Great Dane weight and a Jack Russell Terrier weight? So I'm going to look at Great Dane, and their average weight is 115. Minus, what is a Jack Russell Terrier? Minus 12. So I would need to answer that question. I would need to figure out, what is 115 minus 12? And that answer would get us 103. So the difference in weight is 103 pounds. So that is how we use a table to answer questions. It's one way of organizing information. The other thing I wanted to talk to you about today is something called in and out boxes or function tables. In and out boxes are used to show patterns in math. They have a rule that has to be done. A number goes into the box, the rule happens to it, and a new number comes out. For example, in this first one, it says the rule is subtract 1. So a number goes into the box, the rule happens, -1, and a new number comes out, 0. So what would happen if 3 went into the box and we had to make that rule happen? Well, 3 minus 1 is 2. So I would write 2 there. Now, sometimes they give us the number that comes out, and we have to figure out the number that went in. So we actually have to do it in reverse, because instead of subtract 1, now we're going to have to take this 4 and add 1 to it, because if 4 plus 1 is 5, let's see if that makes sense. If 5 went in and we subtracted 1, do we get 4? Yes. Now, sometimes the in and out boxes go up and down. So in this one, the number that went in was 3. The rule was add 2, so we did 3 plus 2, and we got our answer of 5. So what would happen if 7 went into that box? Well, 7 plus 2 would get us 9. Now again, sometimes we can have to do it in the reverse order, where we have a 10 that came out, but we need to know what number went in. Well, if 10 came out, we would have to do the opposite here. So we'd have to do -2, which would get us 8. Let's see if that makes sense. 8 plus 2 equals 10. That's where a lot of kids get mixed up, is when they have to go in reverse. So in and out boxes can either be vertical or horizontal. Sometimes you have to figure out the number that goes in. Sometimes you have to figure out the number that came out. Sometimes you even have to figure out the rule. For example, if we look at this in and out box, 3 went in and 6 came out. 8 went in, 11 came out. 13 went in, 16 came out. Can we figure out what that rule is? What happened to all of these numbers? Well, I noticed that they all got bigger by 3. So our rule was that we had to add 3. Now, what number would have been our in number then if the rule is add 3? Again, remember, we have to go in reverse. So we'd have to do 10 take away 3 equals 7. Let's see if that makes sense. 7 plus 3 equals 10. Yep, we got it. So sometimes you have to look at it and figure out what the rule is. Is it the number getting bigger or smaller? Are we adding or subtracting? In this problem, 3 went in and 1 came out. So the number is getting smaller. So we wouldn't be adding as the rule. You're going to finish this page on your own, and you're going to do the same thing on the next page, where you're going to have to figure out, if this is the rule, what numbers went in or out. Sometimes you have to figure out the rule. And then there is a word problem that goes with this. So you have to think, if Chris's age is the in box and Pat's age is the out box, what is happening to their ages? And answer the questions. One final page, and I'll go through some of this together. It says functions can be shown in a table, a graph, an equation, or in words. When a table is used to show a function, the rule is shown in words at the top of the table, and the input value x is in the first column. The output value y is in the second column. That's a fancy way of saying that this first box is the in box and the second box is the out box. And they just labeled it with X and Y to show how we can use algebra. So for their example, they said the rule is that you're going to add 2 to X, or you're going to add 2 to the inbox. So 0 plus 2 would equal 2. 1 plus 2 would equal 3. Down here, we need to figure out the rule. 1 went in, 5 came out. 2 went in, 6 came out. I notice it's getting bigger. So it looks like they are adding 4 each time. So the rule is add 4 to X. So we're adding 4 to the number that goes in. So if 3 went in, we know that the number 7 would come out. What if 8 came out? What number would have gone in? If you said 4, you are correct. So we need to do the same thing for 2, 3, and 4. I'll do one more with you because these get a little bit tricky. So this one, 0 went in, 0 came out. 8 came in, 24 went out. 6 went in, 18 came out. Now this one is different because this one we are using multiplication. So what number could we multiply by to get our outputs? Well, I know 0 times anything will be 0. 8 times what equals 24? Well, 8, 16, 24, so times 3. 6 times what equals 18? 6, 12, 18, 3. So our rule is to multiply x by 3, or times 3 would be the rule. So 4 times 3 would be 12. What number times 3 would get us to 6? Did you get 2? 2 times 3 equals 6. Good. Let's see here. Let's do one more because this one is another multiply. We have this number going in, this number coming out. 3 went in, 15 came out. 5 went in, 25 came out. Can you tell what we're multiplying by? We are multiplying by 5. Good, because 3 times 5 is 15. 5 times 5 is 25. So what number times 5 would equal 10? Did you get 2? You are correct. What about 7 times 5? 7 times 5 is 35. And the last one, what number times 5 would equal 20? Well, 5, 10, 15, 20. There's 4 5s in that number. So I will let you do this last one by yourself. It is an addition one. I'll give you that clue. So you need to figure out what the rule is and fill out the rest of the chart. So you should have done the first page together with me. The second page we did a few together, but you're going to finish that page. You're going to do this page all on your own, and then you're going to do number 4 here. If you have any questions, please let me know, and we can review this more another time.